The previous notes were on rational functions. Today we're going to get into more detail about the graphs of these rational functions. Now what you see in front of you, some of this was discussed in the previous notes. Some is from something in the last unit. So let's talk about these y-intercepts and x-intercepts, which are a couple new things here. Now, we all know what a y-intercept is. That's where a graph goes through the y-axis. So those are points like 0, comma, something. To really define your y-intercepts, what we do is we plug 0 in for x. And likewise, x-intercepts are where the graph goes through the x-axis. These points are something, comma, 0. So to find x-intercepts, we plug 0 in for y. Okay, now we saw in the previous notes that vertical asymptotes are the zeros of the denominator. We'll get it down again. Horizontal asymptotes, here's where we have the three cases, so I'll get those down again. If your power on top is less than the power on bottom, then it's the x-axis. If the power on top is equal to the power on bottom, then it's the line y equals a over b, where a and b are the leading coefficients. And if the power on top is greater than the power on bottom, then there are no horizontal asymptotes. And holes. Anywhere we can factor and simplify, we will find a hole in the graph. Okay, so there's some of the basics of these graphs. Let's get into our first example. So first example, here it is. And first thing I always like to do before we start is just try to factor what's on top and bottom. And this will tell us if there's any holes. It'll help us later when we find zeros. If we factor what's down here, it's x minus 2 times x plus 5. Factoring what's on top, it's 2 times x plus 2. So nothing can simplify, so we won't have any holes in the graph. Okay, let's jump into, and I'm just going to go in order what was on the previous page. First thing there was y-intercepts. So the y-intercept, that is if we plug 0 in place of x. And if we use the original function, we get 4 on top, negative 10 on bottom. So plugging 0 in place of x, we get negative 4/10 for a value for y. So this graph will go through the y-axis at the point 0, negative 4/10. X-intercepts. Well, to find x-intercepts, these are the points where if we plug 0 in place of y, what do we get? Well, let's think about this. If we plug 0 in place of y, so I put 0 right here in place of this y, how do we make this fraction equal 0? Well, the only way to make a fraction equal 0 is if what's on top is equal to 0. So what we want to do is find the zeros of the numerator. So I'm going to put a hint to myself here. X-intercepts are the zeros of the numerator, which means set what's on top equal to 0 and solve for x. Well, if we set this equal to 0, dividing by 2 does nothing. Subtracting 2, we get x equals negative 2. So this is really saying if we plug negative 2 in place of x, we'll get 0 for a value for this function. Okay, so we've got 2 points on our graph already. All right, let's talk about vertical asymptotes. In this case, there will be 2 of them because there's 2 zeros of the denominator. There's going to be an asymptote at x equals positive 2 and at x equals negative 5. Horizontal asymptote. The power on top is less than the power on bottom, so we don't have to do any work. We just know that the x-axis will be a horizontal asymptote. And one other thing we know, there are no holes on this graph because nothing's simplified. Okay, so let's get down everything we know. We know there's a point at 0, negative 4/10 right about here. We know there's a point at negative 2, 0 right about here. We know there's a vertical asymptote at x equals 2. We know there's a vertical asymptote at x equals negative 5. And we also know there's a horizontal asymptote on the x-axis. Okay, now we know our graph is going to somehow curve between these asymptotes here. Okay, one thing we could do is choose some values of x, find some values of y. We could use our calculator as a tool to give us an idea where this curve is at. Either way we do this, we're going to see a curve that looks something like this. It's going to be in this corner of our graph. There's going to be a shape in the middle that goes through those 2 points right there. And there's going to be a curve over here in the top right corner. Choosing some points could verify this. Using a graphing utility could verify this as well. Okay, so the work today is going to be very similar to yesterday's, except now we're talking about these intercepts as well, which is an idea we already knew about. Now there's going to be something else that's going to come up today as well, the idea of a slant asymptote. Sometimes we don't have any horizontal asymptotes, but we have asymptotes that are at a diagonal. These are called slant asymptotes. These occur if and only if n, the greatest power, the degree on top, is exactly one more than m, the degree on bottom. If this happens, you will get a slanted asymptote. So let's take a look at a couple examples of this. So second example, here it is. We've got to graph this. Notice the directions just say graph, but I'm going to find all those things that we were asked for before because these are great tools for us to use when we are graphing. So first of all, y-intercept is a point where we plug 0 in place of x. So if we do that, we get 1 on top, we get negative 1 on bottom. X-intercepts. These are the zeros of the numerator. So if we set this equal to 0 and solve, well, I'm just going to think about the quadratic formula here. So if I set this equal to 0 and solve, I can use the quadratic formula. So I can say x equals negative b plus or minus the square root, don't mind me, b squared minus 4ac all over 2a. Now, as you can see, just from that little setup, we've got some negative value in our square root sign, so we won't have any real values. So there's not going to be a real number to put in here for an intercept. So guess what? We're not going to have any intercepts here. So instead of this point here, oh, that's not what I meant to do. But instead of that point there, we just say there are no x-intercepts because there are no zeros of the numerator. Okay, vertical asymptote. Now remember, your vertical asymptotes are the zeros of the denominator, so we can say there's going to be one at x equals 1. Horizontal asymptote, there's none of those. The reason why we know there's none, if the power on top is greater than the greatest power on bottom, there just won't be any. In fact, since the greatest power on top is 1 more than the greatest power on bottom, there's going to be a slant asymptote. All right, before we get into that slant asymptote, let's just state here there are no holes because, well, since we couldn't factor or do anything with what's on top, we can't simplify with anything on bottom, so there's not going to be any holes. Now this one's different because we do have a slant asymptote, but where is that slant asymptote at? Here's how you find it. If we take the top, divide by the bottom, what we get is going to give us the equation of our slant asymptote. Now if you remember your synthetic division, the easiest way to divide these is like so. Add down, multiply diagonally, and we don't get a remainder of 0, but it doesn't even matter. This tells you what the equation of that slant asymptote will be. So the slant asymptote is going to be a line, y equals 4x plus 2. Okay, so let's get everything we know. First of all, we know the y-intercept is at 0, negative 1, so it's going to go right through here. We know there's a vertical asymptote at x equals 1. So the graph's going to approach but not touch this line here. And we know there's a slant asymptote at y equals 4x plus 2. Remember, this is the line with the y-intercept of 2 and a slope of 4. So I will get that on here, and then I will connect those points and extend the line. Okay, we can do some choose x, find y. We can use a graphing utility. Either way, you'll see that this curve goes between these two asymptotes in this lower left corner and up here. In fact, if you use your graphing calculator, you probably won't see this part of the graph until you zoom out. So that's what this graph will look like. All right, let's take a look at one more of these. One more with the slant asymptote, and then we'll call it a day for these notes. Okay, before we get into our slant asymptote, let's just talk about our intercepts. So first of all, our y-intercept, that's if we plug 0 in place of x. We get on top -1, on bottom we get 2. Our x-intercepts are the zeros of the numerator. Now if we factor what's on top here, we'll see we'll get 2 zeros of that numerator. So x-intercepts, we plug 1 in place of x, we get 0 for y. If we plug -1 in place of x, we get 0 for y. Okay, vertical asymptote. These are the zeros of the denominator, so x equals -2. Horizontal asymptote, well, since the power on top, the greatest power on top is 1 more than the greatest power on bottom, there are no horizontal asymptotes. We're going to see a slant asymptote instead. And since nothing could be simplified, there are no holes in this graph. Okay, let's talk slant asymptote. To find the equation of that, we have to take what's on top divided by what's on bottom. So I'm going to use synthetic division again. So 1x squared plus 1x minus 1 divided by x plus 2. So I'm going to put a -2 out here. Adding down, multiplying diagonally. We have a remainder of 1, but it doesn't matter. Our equation is going to be y equals 1x minus 1. Okay, so let's get everything we know. We know the y-intercept is at 0, -1, or excuse me, -1/2, so that's this point right here. There are two x-intercepts at 1, 0, and -1, 0. Okay, so that's here and here. So we've got some points clustered together right here. There's a vertical asymptote at x equals -2. So just over here, we'll see. There's a slant asymptote at y equals 1x minus 1. So it's going to be somewhere in here. And again, we could choose some x's, find some y's, or we could use our graphing calculator to help us out. But we're going to see that this graph will be between these asymptotes down here, and it'll come in here, hit all three of these points, and be between these asymptotes up here. Okay, so that's how to deal with slant asymptotes. We've got some homework we should be practicing on page 161. Give this a shot. This will wrap up this unit.